Hello viewers, hope you all are having a good day. This is Soham from SNS Learning, wishing you a hassle-free learning ahead. In today's tutorial, we are going to learn about binary search algorithm. We will see what binary search is, how binary search implements its strategy and finds out an element from a list of elements, and then we will implement it using Python. There are multiple or couple of ways one can implement binary search. In this tutorial, we will follow recursive approach. If you are new to recursion or recursive approach, I would suggest go and check my previous tutorial about recursion and then come back here. It would be easier to understand. I'll provide the link in the description box as well as at the end of this video. So let us start by understand what a binary search is. So as the name suggests, it's a searching algorithm where an input will be a number or an object, and our job is to find out the position of that number or the object from a list of sorted objects or sorted numbers or sorted elements. So as I have just said, one of the primary condition or prerequisite of applying binary search is the elements or the objects on which you are going to apply this strategy or this algorithm that needs to be sorted. Otherwise, binary search won't work. Next, let us understand how or why it is named as binary search. Why not unary? Why not tertiary? So as the name suggests, binary, which means that at any point of time of your solution, you will have only two choices and your answers should be within that two choices only. So let me explain it a bit detailed way. So let us see how binary search works. Let us consider this array as the elements of number from which we are going to find a position of a given number. Let's say we are going to find the position of 100. Okay, so our input is 100 and we are going to apply binary search on this array. Let's say the array is A. How binary search works? It follows a divide and conquer strategy. Now, as you know what a divide and conquer strategy is, I have already explained in my previous tutorial on merge sort. I'll provide the link in the description box. If you need it as a reference, just go and check that out. So as divide and conquer approach, we will divide this list into two sublists. Let's say we call it a mid. So we are representing it as M. How to calculate M? Now we can simply calculate the mid of this array. Let's say for example 45, because it's so that we can equally divide this array. So M is equals to, M holds the position of that array. If this starts from 0, this should be 1, this should be 2, this should be 3, this should be 4, this should be 5, and this should be 6. So M is now 3. Now we will check whether 100 is greater than A of M or not. Now A of M is equals to 45. Beg your pardon that I am actually using mouse to write this on the screen, so you may find it horrible. Anyway, so now 100. Now we will compare 100 against 45. Whether 100 is equals to 45? No, it is not equals to 45. Now we will check whether 100 is greater than 45 or lesser than 45. Now 100 is not lesser than 45. It is greater than 45. Which means that 100 should be somewhere in this part of the array. Why I am saying that? Because it is already sorted in ascending order. So if 100 or our search element is greater than mid, it should be in the right side because it's ascending order and all the greater elements from mid should be on my right array. So I can simply ignore this portion. Thus, I am reducing this much of comparison. Okay. Now let's take another mid. Let's say for this time our mid is 100. So 100 is basically, so m becomes 5. Now my am becomes 100. Now I will do the same checking again. Whether 100 is equals to 100. Yes, 100 is equals to 100. So I simply return the m. m is pointing to 5. So my output is equals to 5. And that's why I wanted. That's what I wanted. So if you see it carefully, why binary search, one of the major advantage of binary search is on each pass I am reducing a number of elements for comparison. Thus, by progressing towards my goal. Now let us understand why it is called unary that binary that I have just explained, that it is not called as unary or tertiary search, because if you see at every pass we are dividing the array on two dividing the array with a two sub array, and our search element would be either in the mid or in the left or right. So at any point of time, either my search element would be in the mid or either of left or either of right. So at any point of time, my solution is there between two arrays, mid and left or right. So this is how binary search works. Now let us get back to Python and implement it in using recursion. Now this is the program. Let me explain it so that it would be easier for you to understand this short piece of code. So I have used recursion here, as I've told. So this is our list of number which is represented as an array, and this is the element that we are going to search for, and this is our function. Okay, so we have 4 parameters inside our function. The first one is the array, the second one is the element that we are going to search, this third one is the starting point of my array, or starting position, starting pointer of my array, which is always 0, and the last one is last pointer to my array, which is always length of array -1, because length corresponds to the number of elements that an array holds, and position is always, the last position is always -1 for that, from that number. So if you see, the length here should be 7, because we have 7 elements in here, 1 2 3 4 5 6 7. So 7 minus 1 is 6. So as array pointer starts from 0, it should end 150, corresponds to a of 6. Now let us get into this code. The first condition, which is called the base condition, right? So if you have followed my previous video on recursion, I have explained what base condition is and how to write base condition when you are developing a recursive function. You can go and check that out. Now this is my base condition. So my base condition is if start is greater than end. Now start is the starting pointer of my array and end is the end pointer of my array. So I would suggest just hold your question that why I have written start greater than end as my exit point a moment. I'll come to this at the end of this explanation. So let us start from here. So this is the pointer that I was talking about, and I've calculated it, as I've just said, the start plus end divided by 2. So let us get back to this page. So my starting point was 0 and my ending point was 6. So my pointer P should be 0 plus 6 divided by 2. that should be equals to 3. So that's what my code says, that now p becomes 3. Now I'm checking if x or 100 is equals to a of pointer. Now a of pointer corresponds to a of 3, which is equals to 0, 1, this one, which is equals to 45. Okay. Now 100 is, if 100 is equals to 45, no, it is not satisfying the condition. Now let us get back to the next condition, or else if part. 100 is less than 45. No, it is not. Here it is saying that 100 is greater than 45. Yes, this condition satisfies. So I am recursively calling that function again. How I am calling this? Look at this very carefully. These two numbers are same as it was. Now my start pointer, or my starting point, has changed. Right? How it got changed? Now I am mapping pointer plus 1 as my start point for this iteration. If you see this picture, my pointer previously was 3. Now, as a starting point, or as a start, I am giving 3 plus 1. Why I am giving it? Just to ignore this portion of the array, because I have already known that my desired number should be somewhere between this portion. So my pointer becomes 3 plus 1, 4. Okay. So my start becomes 4. So what would be my new pointer? Just a small correction that I have to do. This corresponds to my start, new start. Okay, let me write it. So this is start. Pardon me for the horrible writing, because I'm using my mouse to write on the screen. So yeah, so my new start has become 4. So end is as it was. So my new pointer becomes 4. This becomes 4 plus 6, which is 10. 10 by 2 is 5. So my new pointer value becomes 5. Okay. Now again the checking would happen. Now let us see what actually a of 5 corresponds to. A of 5 corresponds to 100. So this is the number that we were looking for. So here this condition will be met. 100 is equals to 100, and we will print number found at position. This pointer would represent the position, of course. So this is the way that we are going to implement binary search. Now let us understand why I have written here the base condition. Let's start greater than end. Let us say I can provide a number, say 1000, which is not at all in the list. But if you see it carefully, while doing the dividing strategy, so in our past, if you remember, the first mid or the first pointer would be 45. Now 1000 is greater than 45. Fine. So it says that my desired number would be this, would be among these 3. So again it would calculate 100 as mid. Now 1000 is greater than 100, so it should be somewhere between the right of 100. So we have only 150 left. So my start and end becomes 6, right? So this becomes 6 and this becomes 6. So 12 by 2. So my pointer would represent 6 now, right? But what a of 6 represent? 150. Now 1000 is still greater than 150. So I will again increase the pointer to plus 1, right? So my pointer is becoming 7 now. Now if you see, I am not going to have any element which pointer is 7. It is going out of the array. So my start is increasing from my end, which means that I have searched the entire array, but I haven't found out the desired number. So I have to stop here. Otherwise, it would be an infinite loop. So that's what the condition. So I think we have done our explanation. Let us run the code. So let us first search a best case scenario. Let's say, for example, we will search for 68. Okay. So let me execute it. Oh, sorry. Number found at position 4. So 68, 0, 1, 2, 3, 4, which is fine. Now let us search a number which is not at all in the list, so that this condition satisfied and it should stop. And it should print search element is not in the list. So 500 is not in the list. Let me run it. Yes, see, search element is not in the list. So which implies that this condition got satisfied and it print this statement. So that's it, viewers. If you like this video, please hit a like, do share and subscribe. Thank you.